So we talked about addition and subtraction with our algebraic numbers. Let's hit on the other operations, multiplication. So we've already talked about stuff like 3x times 7x, where we're going to combine the counts. 3 times 7 is 21. And then we're also going to combine the names. X times x is
X squared.
X squared. We've talked about not needing the same name when we multiply. We can have 8x times 4y. We're still going to just combine the counts. Excuse me, 8 times 4 is 32. And then we're going to combine the names. X times y is just xy. Now there are some rules with those powers. Here we only dealt with x's and x squareds. If I have an x squared times x to the 5th, what's that end up being? X to the 7th. Good. The definition of x squared, of course, is x times x. X to the 5th is saying there are 5 of those x's multiplied together. If we multiply them together, we now have 1, 2, 3, 4, 5, 6, 7 x's multiplied together. It's x to the 7th. So we are multiplying, but the appearance is the powers just get added. So we could have 7x to the 3rd times 2 x to the 8th. We're going to multiply the count. 7 times 2 is 14. X to the 3rd times x to the 8th?
X to the 11th.
X to the 11th. Perfect. Let's look at now, instead of just doing one-digit numbers, let's multiply a single-digit number times a two-digit number. This, believe it or not, is no different than having 3 times 42. If I were multiplying this out by hand, I would set it up with the longer number on top, 42, times 3. And remember, when we multiply, because we don't need the same names, we're not restricted to only combining things with the same place value. Every digit of one number can combine with every digit of the other number. So I can do 3 times 2, which is 6, and then I have to do 3 times 4, which is 12. This works pretty much the same way. I have the longer number, the 5x plus 2. I'm going to multiply by the shorter number, which is just the 3x. 3x times 2 is 6x. It's positive, so I'm going to put a plus in front of it. 3x times 5x? 15x squared. Perfect. So you can see the multiplication is the same as our multiplication with whole numbers. Now, many of you were probably taught a shortcut. And that shortcut was called distributing. Distributing is nothing more than a way of saving paper and space. So where we condense this process into just simply doing this. 3x times 5x is 15x squared. 3x times 2, positive 6x. We get the same result, it's just this is a little bit shorter. When we start doing these, I will do some of them out like this at first, but eventually I'm going to flop back using the distributing shortcut just because it saves time and space. So if we have 7 times 3x plus 9. Where do I start?
97.
7 times 9 is 63. Yep. 7 times 3x is 21x. Now, if you were using the distributing shortcut, yes, you're right. It would have been 7 times 3x is 21x. 7 times 9 is positive 63. It's the same result. This is just going a little bit backwards to shorten it up is all. Is there anybody that really, really prefers doing it the long way? Okay, I'm going to go back then to I'm going to be using the distributing shortcut then from now on today.
Right up the answer would be 21x.
Yep, 21x plus 63. You have to have that operation in there to connect them. So it's a positive 63, so you put a plus in there. Negative 63 would be a minus. Yep. We can multiply two two-digit numbers. We write them out just like we do our whole numbers. We start with the last digit of the bottom number, negative 7 here. What's negative 7 times 5? Negative 35. But then we also have to multiply the other digit by the negative 7. What's negative 7 times 3x? Negative 21x. Now when we move over to this other digit, what do we have to do down here? Put in a 0 or leave a space, right? 2x times 5x? Or 2x times 5, I should say. It's 10. 2 times 5 is 10x. Positive, so I'm going to put a plus in front of it. Now it's 2x times 3x is 6x squared. And now I'm going to combine what has the same name. I have negative 35 is just negative 35. Negative 21x and positive 10x. Negative 21, positive 10 leaves me at negative 11. So it's negative 11x. And then the 6x squared. Now, many of you were probably taught a shortcut with these called FOIL. What's the F stand for? First. That means you multiply the first two digits. 3x times 2x is 6x squared. What's the O stand for? Outside. So you multiply the outside two digits. 3x times negative 7, which is negative 21x. What's the I stand for? Inside. So you multiply the inside two digits. 5 times 2x?
10x.
Positive 10x. And the L stands for? Last. 5 times negative 7 is?
Negative 35.
Negative 35. So now we combine what we can. There's nothing to combine with the 6x. Negative 21 and positive 10x is a negative 11x. And we have the negative 35. Notice it's the same answer. FOIL is just a little bit shorter and quicker. I'm not a huge fan of FOIL. To me, this makes more sense because that's how you actually multiply it out. The other thing is, what if we run into something like this? FOIL isn't going to work anymore. We got this middle term now. It would be FOIMOIL. But if I do it out doing long multiplication, the process is going to look exactly the same as it did before. 7 times 3, so positive 21. 7 times negative 5x. Negative 35x, good. 7 times 2x squared. 14x squared. Move over to the 3x. We're going to leave a 0 here, or space. 3x times 3. Positive 9x. 3x times negative 5x. Negative 15, x squared, good. 3x times 2x squared.
6x cubed.
6x cubed. 3 times 2 is 6. X times x squared is x cubed. And now we've got positive 21 and 0 is just positive 21. Negative 35 and positive 9 is a negative 26x. Positive 14 and a negative 15 is a negative 1x squared. Or I can just put negative x squared. I don't need the 1 in front of it. Just like an inch, I can have 1 inch or just an inch. And then 6x cubed has nothing to combine with it. Now, yes, I do admit if you know FOIL, you can adjust it and just do, adding the extra steps into it as well. We're not going to do a lot of this anyway with multi-digit numbers. We will do a lot of this distributing up here, where we have a single digit times those multi-digit numbers, because that comes up a lot in the equations we're going to do. Division is not nearly as important, but we're going to take a quick look at it. Let's say we got 36x to the third divided by 9x. We divide the counts first, so it's 36 divided by 9. 4, good. Now we divide the names, x to the third divided by x.
X squared.
X squared, good. You think of that, x to the third is x times x times x divided by x. Think of it kind of like with fractions. You can cancel out a common factor. You can cancel out the x. And you're left with x squared. In business, dividing by algebraic numbers, again, is not a very common usable skill, so we're not going to do a lot of time with that. So let's get on to the main point of the night. The main skill that you're going to have to be able to do to solve problems and solve business applications. It comes down to things that look like this. X equals 7. A variable equals a number. That is called an equation. And it all comes down to this symbol right there. What's that symbol?
Equals.
Equal sign. What's it mean? The same as is a good definition, yeah. Most groups struggle to define it without using the word equals. And it's the same as. What it's saying is, what's on one side has exactly the same value as what's on the other side. In fact, you can think of it as a scale that is perfectly balanced around the equal side. What's on the left side has exactly the same weight, or exactly the same value as what's on the right side. All equations start out this way, as a variable equals a number, or the other way around, a number equals a variable. And they are built from there. How can we build an equation or build onto an equation? Well, we can use one of our basic operations. Add, subtract, multiply, divide, and we even have powers and roots now that we can use as operations. In engineering, there'd be logarithms and exponentials. We're not going to get into those. Well, let's just take a look. One of the things we could do is add. Let's add 4 to this. So this now becomes x plus 4. Now, by adding that 4 to one side, this scale is going to tip unless I do what? Add 4 to the other side. I have to do exactly the same thing to the other side to keep it balanced. I add 4 to the left side, I have to add 4 to the right side. 7 plus 4 is 11. I have now built a more complex equation. I built it by adding 4 to the variable. So what I did to my variable, what I've done to my variable, to x in this case, is I've added 4. Now, more often than not, you're not going to be asked to build an equation. You're going to be asked to do something called solve an equation. The command solve, or the request to solve an equation, is asking us to look at this equation and take it apart. Get it back to this stage here. Well, this equation was built by adding 4. How are we going to take that apart?
Subtract 4.
Subtract 4. If we subtract 4, that removes that 4 and leaves us with just an x. Now, to keep the scale balanced, we have to
Same thing on the other side.
do exactly the same thing on the other side. Subtract 4 from the other side. 11 minus 4 is 7.
7.
So x equals 7. It's right back where that equation started. So that's telling us that x has a value of 7. Now, we built that equation, so we know how it was built. We knew how to take it apart. The key is being able to look at an equation and figure out how it was built. So we might have y minus 2 equals 9, or 9 equals y minus 2 in this case. To figure this out, we first find the equal sign. It's right there. We identify what side of the equation has the variable on it. That's over here. So step 1, locate equal sign. Step 2, find the variable. Step 3 now is to ask yourself, what is keeping the variable from being alone on that side of the equation? So right now it's the 2. So along with that, what operation was used to build on or to attach that variable, that number to the variable? How is the 2 attached to our variable here? How is the 2 attached to our y? What operation? It was subtracted. So then if it was subtracted, how do we take it off? Add. The opposite of subtracting. Exactly. The opposite of subtracting is adding. So the opposite of subtracting 2 is adding 2. Makes that go away. Leaves us with y. Now, as we've been saying, whatever we do to one side, we have to do exactly the same to the other side. So we have to add 2 over here. 9 plus 2 is 11. 11 equals y. We've solved the equation. If we wanted to check our answer, we can put 11 back in where the y is and verify to make sure we have the same value on both sides. So instead of 9 equals y minus 2, I've had 9 equals 11 minus 2. So 11 minus 2 is 9. So there it is, with the same value on each side. We might have 7z equals 42. Let's go through the process. Here's the equal sign. Which side has the variable on it? Left side, right?
On the left.
What's keeping that variable from being alone?
7.
7. And it was attached with what operation? It was
Multiplication.
multiplied. 7z means 7 times z. So to get rid of it, we need to divide.
Divide by 7.
Perfect. Dividing by 7 makes that go away, leaves us with z. And of course, we have to do exactly the same thing to the other side. 42 divided by 7 is 6. So again, we can check this by putting the 6 in where the z is. Instead of 7z, it's 7 times 6. Does that equal 42? Well, 7 times 6 is 42. So yes, it does work out. It does check out. Well, these are simple one-step equations. Those of you that know me from other classes know I always make it worse. We might have 3x minus 2 equals 19. So we identify our equal sign, find the equal sign. We identify what side of the equation has our variable. It's the left side. Now this time there are 2 things that are keeping our variable from being alone. We have the 3 and we have the 2. What operation is attaching the 3?
Multiplication.
Multiplication. How about the 2? Subtraction. So we have to ask ourselves what was done to our variable to build this equation. Well, we've subtracted 2 and we've multiplied by 3. According to our order of operations, what happens first? Would we multiply first or would we subtract first? Well, if we have x, order of operations says you're going to multiply by the 3 first, right? So when this equation was built, x was multiplied by 3, then the 2 was subtracted. That's how this equation was built. Now, what was messing a lot of you up is you were trying to jump in to solve it right away. To solve this, we have to take it apart. Now, if you think about it, if you put something together, whether it is a piece of furniture you buy that has to be assembled, or a toy that for your kids, or whatever, if you've just finished putting it together, you've just put on that last piece. If you need to take it apart again, what's going to be the first piece you take off? The last piece you put on. The last piece that was put on here was subtracting 2. That has to be the first piece we take off. We take it off by adding 2. So that piece is gone, leaves us with 3x. Now we added 2 to one side, we have to add 2 to the other side. 19 plus 2 is 21. So we've removed the subtracting 2. Now we have to get rid of the multiplying by 3. We're going to do that by dividing by 3. So that 3 is gone. Leaves us with x. We have to divide the other side by 3. So 21 divided by 3 is 7. Once again, we can double check. If I replace this x with 7, this is 3 times 7 minus 2 equals 19. 3 times 7 is 21. 21 minus 2 is 19. So I do get the same value on each side. So x equals 7 appears to be the correct value for x. So what if we have 5y plus 4 is equal to, so 59. So 59 equals 5y plus 4. In your notes, try to solve that for me quick. I'll give you about a minute. Okay, so what's our first step?
Subtract 4.
Subtract 4. So I subtract 4 from both sides. So 55 equals 5y. And then?
Divide by 5.
Divide by 5. Good. So that 5 is gone. Leaves us with y here. 55 divided by 5 is 11. Now at this point, I'll leave it up to you guys to go back and double check it. You can double check it by replacing the y with 11. So 59 would equal, instead of 5y, you'd put in 5 times 11 plus 4. You have to do your order of operations to combine that. So when we look at one like this, we find our equal sign, which is right here. We go to identify which side has the variable on it, and we see that our variable appears twice. But both the 2x and the 3x are on the same side of the equation. So if we're thinking of this balanced scale, can we put the 2x and the 3x on the same side of the scale? Can I just push them together and make one big pile? Would that change how this balances? Yeah, it wouldn't change anything. I can do that. I can go ahead and just push them together. 2x and 3x make 5x. This equation here is equivalent to the one we started with. I just combined like values. And now, of course, it's going to solve just like some of the others we have. What do I do first? Add 5, good. So 5x equals 35. And then? Divide by 5, very good. X equals 7. Now again, you can go back and replace each x with 7. So instead of 2x, it's 2 times 7 minus 5 plus 3 times x. And double check to make sure it works. I'll let you guys do that on your own time if you want to. Here, we find our equal sign. We go to identify where the variable is, and we see that once again the variable appears twice. What's the difference this time, though?
There's one on each side of the equal sign.
Exactly, there's one on each side of the equation. We can't just push them together anymore. They're on opposite sides of the scale. To deal with this, we have to get rid of one of the x's. To get rid of it, and mathematically, to get rid of something, we subtract it. It's easier to get rid of the smaller one. Which one is smaller, 5x or 3x? 3x. So I'm going to subtract 3x. It is now gone, leaving just 18 over here. Now I took 3x off of one side. I have to
Take it off on the other side.
take it off the other side. Where can I take it from on the other side? 5x.
5x.
5x minus 3x is 2x.
2x.
Can't forget this negative 2 here. So that now becomes 2x minus 2 equals 18. Now I'm going to pause there. Any questions on where this equation came from? Okay.
Do it again, because I was starting to solve on each side of the equal line.
Okay. Yeah, you can only solve, you can only have one variable or one appearance of the variable to solve an equation. So we have to get the variables together before we can solve. So here, we have to get rid of one of the x's. And it's usually easier to get rid of the smaller one, which is the 3x. So I subtract 3x to make it go away. So all I'm left with on the right side is the 18. Now I took 3x off of the right side. I have to take it off the left side as well. The only place I can take it away on the left side, I can only take x's away from other x's. So I can take it away from the 5x. 5x minus 3x gives me 2x. And then I still have that minus 2 or negative 2 there that I have to keep. Now, I solve this just like I have my other equations. What's my next step? Add 2. So the negative 2 is gone. I just have 2x. 18 plus 2 is 20. And then divide by 2. X equals 10. Again, you can plug the 10 back in to replace x and verify that both sides come out to 48. And it will. Well, verify that both sides come up to the same number, which will be 48. Put it that way. Any questions? What's that?
Should we be taking all the concepts we learned with our first number assignment and applying them into algebra?
Kind of. We're going to end up with some equations with fractions in them before we're done. So, I want you to try this one in your notes. This one combines a couple of things we looked at. I will give you a hint. Take care of each side separate. If there are things you can combine on each side, do that first, and then worry about doing things between the two sides. But I want to give you a minute to see if you can figure out how to do this one. Okay, let's see how you're doing on this. If you're not done with it, that's fine. Let's see how you've done so far. I gave you the hint, take care of each side first. Well, on the left side here, there's nothing we can combine. That side is as simple as we can make it right now. On the right side, is there anything we can combine?
3x and 4x.
3x and 4x, which combines to make
7x.
7x. So it's 7x minus 11. So we have 5x plus 7 on the left side, 7x minus 11 on the other. Now there's nothing more we can do on each side right now, so now we can work on putting the two sides together. Before I solve, though, there's still one more thing I have to do, which is,
Subtract 5x.
yeah, I have to get rid of one of the variables. The variable appears twice, and I can only solve an equation where the variable appears once. So I have to get rid of the 5x. I subtract 5x to make it go away. That leaves me with 7 on the left side. Where do I take the 5x from the right side? From the 7x. 7x minus 5x is 2x. And the negative 11 is still there. Minus 11 is still there. Now what? Add 11. So we've got 18 equals 2x. And then divide by 2. So 9 equals x. Any questions? Okay. Well, let's look at something else that's a little bit different. What's different about this equation that we haven't seen before?
The parentheses.
The parentheses. Whenever we see parentheses, it should scream at us. Do something here first. Now, some parentheses are an enclosing symbol, like we said, saying you have to do something inside of them first. Other parentheses are just a separator, which separate a number from the rest. The difference is, in an enclosing symbol, we can do something inside of it. So that's always our first question with parentheses. Is there anything I can do inside the parentheses here?
Nope.
5x and negative 7 can't be combined because they have different names. And we're subtracting, so they have different names. So 5x minus 7 has to stay like that. So now it's not an enclosing symbol. We're not doing anything inside of it. The next question is there anything we have to do to it?
Yes.
Multiplied by 3. So we're going to go ahead and use the distributing shortcut here. 3 times 5x?
15x.
15x. And 3 times negative 7?
Negative 21.
Negative 21. Always remember that this operation in front of the number goes with the number after it. So it's minus 7, but it treats it like a negative 7. So 3 times negative 7 is negative 21. So that becomes 15x minus 21 equals 24. Nope, the 3 only multiplies what's in the parentheses. We're at the end of the parentheses, so we're done with the 3. Now what do? Add 21.
That's my 21.
Perfect. So the 21's gone here, gives us 15x. 24 plus 21 is? 45. 45. There we go. Next. Divide by 15. So it cancels out the 15 there to give us x. 45 divided by 15 is 3. Perfect. I want you to try this one in your notes. See if you can make that work. So tell me where to start. 7 times 2x. So
14x.
7 times 2x is 14x. Good. And then?
7 times 1 is 7.
7 times 1 is plus 7. Got the 77 over here. Now I heard someone say divide by 7. In this equation, you could have divided by 7, but that doesn't always work out. I'm going to show you an example in a second where that wouldn't work. So it's always safest to distribute the 7 when we have a parentheses like that. Distribute the number that's multiplying the parentheses. What's our next step?
Subtract 7. Subtract 7.
Subtract 7. So this is 70. Here the 7's gone. That's just 14x. And then? Divide by 14. So 5 equals x. Again, you can put the 5 back in there for x. 2 times 5 is 10. Plus 1 is 11. 7 times 11 is 77. To double check it. I know I went kind of fast, but I'll trust that you guys can do that on your own if you need to. So I promised I was going to show you an example where dividing by the 7 wouldn't work. And here it is. Here I could not divide by 4. I mean, I could, but I'd have to be very, very careful. It'd be really easy to make a mistake. I have the parentheses here. Is there anything to do inside the parentheses? No. Anything to do to the parentheses? Yes, times 4. 4 times 5x? 20x. 4 times negative 3? Negative 12 or minus 12. Now we're at the end of the parentheses, so we're done with the 4. We do still have minus 8 there. Now that we're done with the parentheses, we have to see if there's anything we can combine. And we can combine the negative 12 and a negative 8, which would be
Negative 20.
negative 20. So now what? Add 20. So 20x equals 120. And then divide by 20. So x equals 6. And again, you can go back and replace the x with 6. It will work out to the same value on each side. Well, since we're having fun, let's step it up a bit. I told you, I always make it worse. It's part of my charm.
My dad had a saying, he said, if it was easy, it wouldn't be any fun.
See, there you go. So here we see that there's 2 sets of parentheses. When we have 2 sets of parentheses, we work left to right. So on the left, we run into this set of parentheses first. Is there anything to do inside the parentheses? No. So we have to see what we can do to the parentheses. That is times the 3. I'm going to tell you a shortcut. Just tell me, what do you get when you multiply the parentheses by 3?
15x minus 12.
15x minus 12. Good. 3 times 5x is 15x. 3 times the negative 4 is negative 12. Now this next parentheses, I got a little trap here. Nothing to do inside the parentheses. So what is it being multiplied by? Yeah, it's not 2, it is negative 2. Good. So negative 2 times 3x?
Negative 6x.
Negative 6x. Negative 2 times negative 7?
14.
Positive 14. So I have to put in the plus in front of it. Now there's still things I can combine on the left side of this equation. What can I combine?
Combine both of the x's.
So I got 15x and negative 6x makes
9x.
9x. Negative 12 and 14 make
2.
positive 2. Good. And that still equals 29 on the other side. Now what?
Subtract 2 on both sides.
Yep, we're back to solving it just like our other equations. We subtract 2. We got 9x equals 29 minus 2 is 27. And then
Divide by 9.
divide by 9. X equals 3. And again, you could go back and replace all the x's with 3's to make sure it works out. Okay. We're a few minutes early, but let's go ahead and take our break, our second break here. It's 7:17. Let's come back at 7:27 to start our last hour.